Hello everyone. So today we shall study about heat transfer. So module 2, transient heat conduction. So today in this presentations we will be studying the lumped analysis problems. Okay. So this is the first problem. So the heat transfer coefficients for the flow of air at 28 degrees over a 12.5 centimeter diameter sphere. So he has given the material in terms of sphere. Okay. Are measured by observing the temperature time history at a copper ball of the same dimension. Okay, so the material is of copper ball, which is in terms of sphere. The temperature of a copper ball was measured by two thermocouples. Okay, one located in the center, another near the surface. Both the thermocouples register the same temperature at a given instant of time. Okay, if one test, the initial temperature of the ball was 65 degrees Celsius, so Ti becomes 65. Okay, and in 1.15 minute the temperature decreased by 11 degrees Celsius. So for the duration of certain time, the temperature will be decreased by 11 degrees Celsius. So the initial temperature will become 65 minus 11, that is 54 degrees Celsius. So he is asking to find the heat transfer coefficient. Okay, H. So as he is given the air temperature, that is ambient temperature is 28 degrees Celsius. So tau he has given in terms of time 1.15 minute, diameter of the sphere. Okay, convert into radius in meters. Okay, he has given C, specific heat and density. Okay, now initially we have to check the Biot number. So Biot number decides whether it is a lumped heat analysis or not. Okay, it must be less than 1.1. Okay, Biot number, the formula is HLC by K. LC is a characteristic length. So for a sphere, the characteristic length will be R by 2. Okay. So here you just observe it clearly. H is the value we need to find. That is heat transfer coefficient. H is the value we need to find, because we need to decide whether Biot number is less than zero point 0.1 or not. We need the value of H, but H is the value we need to find in this problem. Hence we assume Biot number is less than 0 0.1. Okay. Now, so this is the formula for temperature distribution across the sphere. Okay. So we know that T minus Ta divided by Ti minus Ta is equals to e power minus Hes divided by rho Vc into tau. So this is the formula we will be getting from data handbook. That is heat and mass transfer data handbook, which is 7th edition. Okay, written by C.P. Kodandaraman from the page number 58. Okay, we'll get this equation. So if we need the value of H, because H is the only unknown value we need to find, so rearrange it in order to get the value of H. So here V by AS, V is the volume of the sphere, AS is the surface area of the sphere. So what is the volume of the sphere? 4 by 3 pi r cube. What is surface area? 4 pi r square. Okay, if we substitute all the known values in this formula, we get the value of H, that is 37.71 watt per meter square Kelvin. Okay, we shall move to the next problem. So next problem, a cylindrical ingot 10 centimeter diameter and 30 centimeter long passes through a heat treatment furnace. So ingot is placed in a furnace which is 6 meter in length. What furnace? The ingot must reach a temperature of 800 degrees Celsius. So this is the ingot temperature. Okay, that is T before it comes out of the furnace. The furnace gas is at 1250 degrees Celsius. That is the gas temperature. That will become your initial temperature. Okay, and ingot initial temperature is 90 degrees. So initial temperature of the ingot, which is just kept before furnace. Okay, so that will become ambient temperature, that is Ta, that is 90 degrees Celsius. What is the maximum speed? He is asking the speed at which ingot should move into the furnace to attain a required temperature. Okay, that is speed, that is velocity is asked. So the combined radiative and convective heat transfer coefficient is 100 watt per meter square degree Celsius. So he has given the thermal conductivity and thermal diffusivity. So we shall start the problem. So initially we need to find to find the Biot number, that is characteristic length. It is LC is equals to V by AS. Okay, understood? V by AS. So this is the important parameter that you need to understand. Okay, characteristic length. Okay, LC, that is V by AS. What is the volume of the ingot? That is pi by 4 d square into L. What is AS? That is surface area. So surface area of the ingot depends on the total along length of the ingot and diameters at the either end which is exposed inside the furnace. That is pi d square by 4 into 2. 2 times defines the either side of the ingot. So if you relocate it, you will get the D and L. If you substitute, you will get the value of LC. Next is the Biot number. Biot number is HLC by K. That is 100 LC, K, that is 0.05 is the value. Now this value is less than 0.1. Hence, internal thermal resistance is neglected. Okay, that is, we can consider it as a lumped analysis problem. As you know, the previous problem we have solved the temperature distribution formula. So this is the temperature distribution formula which you will be getting from the data handbook. Okay, in this you don't know the value of rho and C. That is, in the question he has not mentioned the value of density and specific heat. Hence we will rearrange this equation in the form HAS divided by rho VC. That is, we just multiply and divided by K. Okay, understood? For this equation, we just multiply and divide by K. Okay, so if you rearrange this equation in the form of K by rho C, H by K, AS by V, we know the thermal diffusivity is nothing but heat conducted divided by heat capacity. So this you can convert in terms of alpha, that is thermal diffusivity. Then remaining rest of the terms H by K, AS by V. You know the values of these three terms. If you substitute the values, you will get the value of HAS divided by rho VC. If you substitute back this value here, so the only unknown is time, that is tau. Okay, if you rearrange and if you calculate, you will get 362.9 seconds as a time. So now he is asking in the question to find the velocity of ingot passing through the furnace. So you know the distance, speed is nothing but distance traveled by time taken. So 6 is a total furnace length he has given in the question. Furnace length you should take, okay, divided by time. So 362.9. So ultimately you will get 0.01653 meters per second. That is the velocity of the ingot which is passing into the furnace in order to obtain the maximum temperature. Okay guys, we shall move to next problem. Okay, so this is the next problem. A 15 mm diameter mild steel sphere, okay, is exposed to cooling airflow at 20 degrees Celsius. So he has given it is exposed, that is ambient temperature, that is TA, 20 degrees Celsius, resulting in convective coefficient, that is H. So he's asking to find the time required to cool the sphere from 550 to 90. So 550 becomes the temperature at the initial, that is initial temperature of the sphere, that is Ti, to 90. T90 will become the present temperature of the sphere, that is he's asking to find the time. Okay, so let's solve the problem step by step. So just note down the values as he has given in the question. The first thing is you need to find the time required, that is initially you have to calculate the characteristic length, that is volume of the sphere divided by surface area of the sphere, as we calculated in the previous one. Just r by 3, if you cancel it you will become r by 3. R, you know, if you substitute you will get characteristic length. Similarly, Biot number is nothing but HLC by K. If you substitute, the value will be 0.007143. Okay. Similarly, Fourier number. So I will tell you why we have to take Fourier number here. That is alpha tau by LC square. Alpha he has given, tau is the unknown value because we need to calculate the time required to cool the sphere. Okay, so keep it in terms of tau. Now, since Biot number is less than 0.1, we can use lump theory to solve problem. Okay, so this is the formula for temperature distribution as we have solved in the previous problems. Okay, now so b e to the power of minus bi, that is Biot number into Fourier number. This we can write in this format. If you substitute these two values, you will get the same answer. Okay, Biot number into Fourier number. As you calculated previously what is Biot number and Fourier number in terms of tau, if you substitute both, you will get the values of tau. This tau is the only unknown. So convert into seconds, you will get tau is equals to 141.7 seconds as the total time required to cool the sphere from 550 to 90 degrees Celsius. Okay. What is second one? He is asking instantaneous heat transfer rate. Heat transfer is asking 2 minutes after the start of cooling. Okay, so he's asking to find the instantaneous rate. The instantaneous heat transfer rate 2 minutes convert into hours after the start of cooling. That is, you know the instantaneous heat transfer formula, that is HA delta T. Just multiply it with e power minus b I to 4. Okay, so you know the Fourier Biot number into Fourier number. Here Fourier number is 7200 into tau, but here we need to take tau as 0.0333 hours. Okay, convert into hours and substitute it. So we'll get the value of Biot number into Fourier number, the value. So reverse back, substitute in the formula equation. As you know, Ti and Ta, H and surface area. So if you substitute, you'll get the Qi as minus 8.1 watts. So what does this negative sign indicates? It is nothing but heat is taken out. That is heat loss from the sphere. Okay. Third one is asking to find the total energy transfer from the sphere during first 2 minutes. That is Q dash. Okay. Total energy transfer. That is Q dash is equals to rho Vc into Ti minus Ti e power minus beta bi o minus 1. This is the formula for energy transfer from a sphere. You know the only known values, just substitute rho v c and e power minus bi into 4. If you substitute back, you will get the q dash is equals to minus 2862.35 as a into watts. So write on the unit as watts. Okay, this is the total energy transfer from the sphere during first 2 minutes. Okay guys, so this is the complete total basic problems for lump rate analysis problems that you need to calculate. Okay, next one, fourth problem. So an egg with the mean diameter of 40 mm and initially at 20 degrees is placed, okay, in a boiling water pan for 4 minutes and found to be boiled to be the consumer's taste. How long should a similar egg for a same consumer be boiled when they taken out from a refrigerator at 5 degrees Celsius? Take the following properties from the egg. So these are the certain parameters he has given. So the egg will be in terms of sphere. So we consider the material as a sphere. Okay. So first we need to calculate as LC, that is sphere for the characteristic length will be R by 3. Okay, you know the value of diameter he has given, convert into radius in terms of meters. If you substitute, you will get characteristics. Substitute back in the Biot number to calculate whether it is less than 0.1 or not. So if you substitute, the value is 0.067, that is less than 0.1. So the temperature distribution with time is given as this is the temperature distribution, as you know. First you have to substitute back. Okay, so here he is asking the T. Okay, so he's asking the T. First you need to find the value of temperature. Okay, so the you know the ambient temperature. Okay, so next is TA, that is 20 degrees. What is ambient temperature? Boiling water. So boiling water ultimately it leads to 100 degrees Celsius, as you all know it. Okay, so he's asking at what temperature will the it takes to attain the temperature boiled egg, because we need to take the considered as 4 minutes, that is convert into seconds. Okay, so in this question for a egg, okay, if you want to boil it, okay, when the initial temperature is 20 degrees Celsius, okay, so ambient temperature of water is 100 degrees Celsius. If you boil it for 4 minutes, what is the temperature it has attained? Okay, that you have to calculate. That is T is equals to 82.82 degrees Celsius. Now at this degree Celsius, what is the time he has to consider back? Okay, at this degree Celsius. Now what is the initial temperature of the egg? So before it was 20 degrees Celsius. Now the initial temperature of the egg is 5 degrees Celsius. Understood? So the egg, the same temperature where the egg is attained, the same temperature we have to take back, and this is the ambient temperature, and 5 degrees Celsius, that is the initial temperature when we take egg from the refrigerator. So the unknown value is time. Okay. Now to reach from 5 degrees Celsius to 82 degrees Celsius, what is the time taken? That is, if we substitute all the unknown values, we will be getting 4.435 minutes it takes. Okay, understood guys? So this is the time required to boil the egg when it is taken out from a refrigerator as per the consumer's taste. Okay guys? So this completes total 4 basic problems as involved in this lump rate analysis in transient heat conduction. Okay guys, thank you.